For this lesson, we're going to find how to actually determine the distance of line segment D. I'm going to put that in red. This is a pretty typical question that you'll see. You'll see it goes from maybe a back corner to a front corner. Also, this one will be at the bottom. This one will be at the top. They could have just as easily have drawn a line from here to the very back corner there. Sometimes maybe they would take the front corner of the top back here and run it back there, but they're looking for a diagonal that's cutting through this three-dimensional shape that we see here, this rectangular prism. Now, it's usually a two-step process, and I would say you need to draw a diagonal on the bottom square or the rectangle in the 3D shape. Then use the Pythagorean theorem to find that information, and it's not going to give you the answer that you want. See, what we've got to do is we've got to try and make triangles in this that are right triangles that we can use Pythagorean theorem. And many times this diagonal line that was already here, to make it a little bit easier for you on the notes, is not there. And so they will just say, hey, what's the distance of line segment D? And you'll see it's an internal diagonal. And then you would need to come in and make this dashed line. And what we're doing is we're creating a right triangle because this is going up at 90 degrees from the base. So we can put a right angle right there. That makes this a leg, and that makes this a leg of a right triangle. So if we could find these two sides of this red triangle, this red right triangle, these two legs, then I could use the Pythagorean theorem to go find D. So now we have to start using what we know about rectangles. You can see the 6 by 12 rectangle right here. Let's just be able to do the following. If this is 6 centimeters, what else has to be 6 centimeters? Well, because this is a rectangle on the front, this 6 centimeters would get this to be 6 centimeters. And because this is a rectangular prism, this rectangle on the back is the same as the rectangle on the front. So every single one of these sides that's going up would also be 6 centimeters. So anything green would be 6 centimeters. So I put in the 6 centimeters there so we can see them. I didn't do one here because I think it'll just kind of get in the way, but yes, this is 6 centimeters as well. So to clarify again, we need to find these two sides of the red triangle, the legs, so I can go find the hypotenuse for this line segment D. What's the distance of this D line segment, the internal diagonal? So if we can just find a way to find this, we'll be okay. Well, the info that we did, because again, a lot of times you'll have to draw this diagonal line in there, lets you create another triangle inside the 3D shape. The distance they want is the hypotenuse of this new triangle. So let me just shade in this new triangle that I see that will be very, very helpful for us. This is a right triangle as well, and the right angle is actually right here. I also know that this is 7. So what else has to be 7 centimeters? Well, in the same way that we did the green verticals, take a look at this one. This 7 centimeters would be here, here, and here. And so for this blue triangle, we now know that the two legs, the A and the B, is 7 and 12. And if we could go find the blue triangle's hypotenuse, it will give us that part of the blue triangle, but it'll also give us the other leg of the red triangle, which is what we desperately need. Carefully put in the information and find the hypotenuse of the blue triangle. So we get about 13.9, and we're going to round it. It's 13.89, so that rounds to 13 and 9/10 there. And so now we're just going to plug that information right there, and I'm going to write it inside the red triangle so we can see it. And now, after all of the setup, we finally have the ability to get the two legs, the A and the B of our red triangle, so we can get what the question wanted. A, find the distance of D. If we can get C, we're in good shape. Let's plug in 6 and 13.9 into our Pythagorean theorem. So we get about 15.1 centimeters, and we still do our check. The hypotenuse should always be bigger than your legs. 15.1 is bigger than the largest leg. So let's just do a restatement. The distance of D is about, because again we rounded, 15.1 centimeters. If you wanted to be precise, find the square root of 229.1 and that would be the exact amount, but we're having to round.